The only way to get good at this process of adding and subtracting is to do it. So let's look at some examples. In our first example, we have 2x over x minus 5, subtract the fraction x over x plus 5. What we have right now is a denominator of x minus 5 and a second denominator of x plus 5. They look like they're very close to being the same, but they're not. There's a big difference between having x minus 5 and x plus 5. So the LCD, because these are both factored, is going to be, according to the rule, the first denominator times any factor that the second denominator has that we don't have already, and that would be x plus 5. So what we have here is an LCD that is basically the product of the two original denominators. This will always be the case when you have two denominators that have nothing in common. You'll always use their product. Now, what we want to do is write each of those denominators with the LCD. And as we do that, we're going to adjust the numerator appropriately. So 2x, the original numerator in the beginning, is going to have an x plus 5 multiplied into it because that's what I put into the denominator to make it a common denominator. And my second fraction, x, is going to be multiplied by x minus 5 because that's how I'm adjusting the denominator. The original denominator was x plus 5 and I need to multiply it by x minus 5. So now I have both denominators with the common denominator. I'm going to go ahead and subtract the numerators. I'm going to list out the common denominators first. You'll notice that I wrote them differently originally in the second line, but you'll just write them one of those two ways when you continue on. When I go to subtract the numerators, I do need to distribute out the multiplication before I do the subtraction. So I'm going to have 2x times x, or 2x squared, plus 2x times 5 is 10x. And then I'm going to distribute the x. So I'm going to get x squared, and I might as well work with the minus here at the same time. So it would be minus x squared. And then don't forget you're going to subtract the next term as well. So the next term is going to be negative 5x. When we subtract it, we get a positive 5x. So watch your subtraction that you distribute it all the way through. Now we can collect like terms in the numerator and actually perform the addition. 2x minus x squared is x squared. 10x plus 5x is 15x. And we have a denominator of x plus 5 times x minus 5. At this point, we have a single fraction. We've simplified the numerator. We can try to factor to see if we get a simplified result or if we're able to simplify. But in this case, you may be able to see it here, where even if we factor this common x in the numerator, we will not be able to find a common factor to cancel. You could, if you do the work and show x times x plus 15 by factoring the x out. There's no reason you can't leave this as your final answer, but it doesn't really help any. So in terms of your final answer, you could either give this fraction or this one below. You can have the numerator factored or not, your choice. We didn't cancel anything there, so we don't have to provide domain restrictions. In our next example, we're going to look for a common denominator again. What we want to do first is factor this second denominator because it isn't factored yet. My first denominator is factored, so I have a fraction of x plus 3 over 2x minus 1. This denominator is as factored as we can do. Our second fraction, though, 3x over 10x squared minus 5x, that denominator has a common 5x in it. So we're going to take out the 5x, and we're going to be left with 2x minus 1. Now that we have factored denominators, we're going to create the LCD by taking the first denominator and then multiplying in whatever is missing from the second denominator. What we have is a 5x that we didn't have in the here already. So generally we'll put the 5x because it is a monomial at the beginning. So I'm going to squeeze it in here and put it at the beginning. So my LCD is going to be 5x times 2x minus 1. That means that my second fraction already has the LCD. So I can actually just rewrite the entire second fraction exactly as it was right at that line. My first fraction does need to be adjusted. I have 2x minus 1 that I have to multiply by 5x, And because I multiply the denominator by 5x, I must multiply the numerator by 5x. So again, if I adjust the denominator in my fraction to make it an LCD, I must adjust the numerator the same way. Now we have a common denominator, 5x times 2x minus 1. We're going to go ahead and add the numerators, but before we can add them, we need to distribute. So I have 5x squared plus 15x, and then I have that plus 3x. Now I can collect like terms in my numerator, 5x squared plus 18x all over 5 times x times 2x minus 1. Now when we look at this final fraction, we can try to simplify if we can factor the numerator. When we look at this numerator, it initially maybe doesn't look like there's much to do because 5 and 18 don't have anything common. But if you look closely, that x is common to both. So I can take the x out and get left with 5x plus 18. And then there's an x in the denominator, this 5x times 2x minus 1. So I can cancel these common x's. So my final result is going to be the fraction 5x plus 18, I no longer need parentheses there, over 5 times, in parentheses, 2x minus 1. Now I did cancel a common factor there, so I do need to provide that domain restriction. And remember, what I canceled can't be 0, so x itself cannot be 0. So when you simplify rational expressions, make sure you provide domain restrictions.